Cryptographic Foundations part project for RSA, created by Lemon 2 and Dervla Larkin. Here we have task 1 of the project, where we execute the extended Euclidean algorithm. As you can see here, we get the GCD by passing in a two int values, which in our case is 13 and 3. So while a not equal to b, and if a is more than b, then we subtract a from b, else we subtract b from a, and we return a. Once that was created, then we created the extended Euclidean algorithm, where we pass in two int values, again a, b, which is 13 and 3. So int a1 is a, y is 0, y1 is 0, delta 0, temp 0. So while b is more than 0, then delta has to be a divided by b, and temp equals a, where a equals b, then a equals b, then b equals temp minus b times delta. Then temp equals y1, y1 equals y minus y1 times delta, y equals temp. And if b is equal to 1 after this, then we return y, then we return this. Else we return minus 1. So when we execute this algorithm, the extended Euclidean of 13 and 3, we should return a 9. Oh, wrong file. Yeah. So as you can see, we returned 9. This is task 2 of the RSA project, where we encrypt and decrypt a message. So as you can see here, we used a big integer to create keys using a create key method that we created. And our string message is here. So what we did first was we converted the message into a big integer, as you can see here, and then we encrypted the big integer using a function that we created called encrypt. Once we did that, we outputted the decrypted message by using the decrypt function that we created using both keys, key 0 and key 2. So create key, as you can see here, it takes the big length, the bit length, 2 to the power of 1000, takes that and then gets a result called, makes a new big integer, called result. Then we have get random rand. So here we are, our big integers of p and q are here. Once we have created those using the bit length and the rand, we then multiply them together and store them into the variable big integer a. Once we did that, we outputted n, so we can show the first part of the process. Once we did that, we multiplied p subtracted by big integer, and then we multiplied that by q subtracted by that. Once we completed that, we find out our e variable by using the big int probable prime. Once we did that, while GCD not n equals big integer dot 1, so basically that just means when the GCD of n equals this, then E will then become the new probable prime, and the result 0 equals E. Once we did that, we created the big D variable, where E mod inverse BHIN. Sorry. So when E inverse is phi n. Once we did that, I outputted D and E to show the answers. Once we did that, we restored D and N into the results array. Once we did that, we then created the encrypt method, also using big integer, where the ciphertext equals a new big integer which equals a string of 0. So the ciphertext, we changed that then to mean message to the power of en, and returned the ciphertext. Once we did that, we created the decrypt method, where the message, again, the message equals a string of 0, and we outputted D and N. The message then was deciphered using the modular power of Dn, and returned the message. And then we just created the encode string, which just passes through the original message and the protocol, and I put a char65. And this is how it ran. As you can see, we have three big ints, and our decrypted message here. And as you can see, it's the same as here. That is the end of my screencast.